You and your friend are playing kick the can down the road, as you do. The can has a mass of 40 grams, so that would be divided by 1,000 to get kilograms. I never trust myself with these ones. 40 divided by 1,000, 0.04 kilograms. Always convert to SI units, even before you finish reading the question, so you don't forget. And your friend kicks it to you with a velocity of 2 meters per second to the right. Part 1. Calculate the initial momentum of the can, including its direction. So we know that momentum is mass times velocity, and momentum is a vector, right? It has both a magnitude and a direction, which depends on its velocity. So in this case, its mass is 0.04 kgs, and its velocity is 2.00 meters per second, and it's to the right. So let's define our coordinate system as to the right being positive. Right, so this will be positive 2, as it is. And calculating that, 0.08 units, momentum mass, kilograms, times velocity, meters per second. And since it's positive, we know that it's to the right. And do we need to round it? No. So the lowest sig fig is the mass, which is 2. So that's fine. Part 2. Of course, you kick it back to the left, so in the opposite direction, with a velocity of 3 meters per second. Calculate the final momentum of the can. So now it's 3 meters per second to the left. It has the same mass, assuming nothing fell off, 0.04 kgs. This time, it's 3 meters per second. Oh, that should be 3.00. I'll update that in the question. 3 meters per second to the left. So we've defined to the right as positive. So we will input minus 3.00, which will give us minus 0.12. Yep. Always doubted myself. Had no reason to doubt myself. Alright, and what are the units? Momentum, kilogram, meters per second. So what is the direction? Well, you'll notice the negative sign tells us that the direction is to the left. So its final momentum is 0.12 kilogram meters per second to the left. Part 3. Calculate the change in momentum, including the direction. So change in momentum, delta P, is equal to the final momentum minus the initial momentum. And we worked out the final, and we worked out the initial. And we've already included the signs, right? Because they depend on the velocity. So the final momentum is minus 0.12. And we take away the initial 0.08. And that would give minus 0.20 kilogram meters per second. And so what's the direction? Well, since it's negative, we know the change in momentum is to the left. And finally, part 4, if the can was in contact with your shoe for 0.2 seconds, right, as you kicked it, calculate the force you exerted onto the can, including its direction. So we worked out the change in momentum. That's above. And the time in contact, was that also 0.2 seconds? Am I tripping? Yep, it was. Calculate the force exerted. So we know change in momentum relates to the force applied times the time of the collision, right? The impulse equation. So rearranging for force, change in momentum over change in time, where we know the change in momentum, negative 0.2 divided by change in time, giving us negative 1 newtons, right? Rounded to one significant figure. All right, because 0.2 seconds is one significant figure. Now, what does this negative mean? Well, it means that the force acting on the can was to the left. And let's just double check to make sure it makes sense. So the can was moving to the right initially, and then you kicked it to the left. So if you're kicking it to the left, this poor can here will experience a force to the left, right, from your kick. So that makes sense. Another question could have been, calculate the force exerted onto your shoe, right? And that would actually be the same magnitude, 1 Newton. However, the can is moving to the right, so the force on your shoe from the can would be to the right. So just double check you're working out the right force and giving the right direction. Cool. Alright, enjoy your can kicking down the road. I'll see you next time.